Okay, so today we're going to be looking at analyzing circuits using Kirchhoff's laws that we looked at, and we're going to be also using Ohm's law. So let's try to do a quick recap. So we have the formulas when dealing with circuits in series and the formulas for the circuits in parallel. And luckily for you, I updated the formula sheet so you can reference these. So in series, we have that the current, what happens to the current in series? Does it stay the same or does it split?
Stay the same.
Stay the same. Stay the same. Whereas the current, if you're talking about a parallel circuit, the current splits into the two different branches. Now, it doesn't really follow communism because it doesn't have to be 50-50. So it's going to follow the path of least resistance. That's where most of the current will go. But one way to write that mathematically is just to say, hey, if we have two branches, the sum of the source, the sum from one branch and the other will equal to the sum of the source. And now if we're looking at the voltage, in series, the voltage has to be split, V1 plus V2, whereas in parallel, the voltage remains the same. And from this, we were able to use Ohm's law, which is V equals to IR, and then we derive equations to how to find equivalent resistance along a circuit. So if it's a series circuit, the equivalent resistance. Now this has many different notations online, so you might find it as R series, and they write the sum of R1 plus R2. I prefer R12 to be R1 plus R2, and yet you might find even other ones they write R equivalent or R total. So it does get a bit annoying because electricity was studied in different parts of the world and then everybody has their own notation. So if you're looking at other resources, they use all sorts of different names for the exact same thing. And for the parallel circuit, the equivalent resistance, again, this one instead is called R parallel. Oh, sorry, it's the reciprocal one. All right, so all of these formulas are given to you in the formula sheet, so make sure that you're going to refer to them as you're doing your homework questions. And which other formulas do we have so far in this unit? We have the formula to calculate. No, Ohm's law we already use. Current. And we have power. And voltage. Remember the voltage? So with this, now we're going to be able to solve other questions. So today all we're going to be doing is just some problem solving. And again, if you do need to refer to the formulas, go to slide 7, right? So let's go to slide 8. So here we have a simple circuit set up in series. And they're asking you in 10 seconds, how many coulombs of charge pass through the circuit? So what's the main formula that we're going to have to use? Which formula relates time, coulombs together?
Current.
Yeah, so current is the amount of charge that goes through a cross-sectional area in a given time period. So if they're asking us how many coulombs, that's another way of asking you what is the value of Q. And in this case, they give you the change in time, which is 10 seconds. But the only thing that we need to find from the circuit is going to be what is the value of the current. So now we have a target. Let's go to the circuit and try to find the current in that particular circuit. So any thoughts how we can approach it?
Voltage times resistance.
Voltage times resistance.
Or is it divide? I can't remember. Divide. Is it divide? I can't remember.
Because this time I didn't tell you the way I remember it, because I got in a lot of pushback from students, because your generation is very soy sauce or no soy cafe no.
Yeah, are you calling us soy boys? Yeah, what are you trying to say? You're more masculine, Mr. Morales?
No, I didn't want to say it directly. I'm trying to say it indirectly.
Soy sauce and soy sauce are black.
What are you calling us soy boys? Mr. Morales, do you base your masculinity based on whether you drink soy milk?
Every morning I take my coffee black.
That seems like a... Okay.
See, this is exactly why I didn't tell you this, because people get so sensitive about it. Oh my goodness, you just proved my point. Okay.
For me, it's soy boy.
So one way to remember Ohm's law is this spells out almost the word virtue. And I used to think of each charge as a soldier, and the soldiers carry the energy with them, and you know, soldiers usually have a virtue with them. So one way to remember Ohm's law is because of V equals to IR, virtue. Again, I'm not going into the whole details of that particular example, but let's just use this Ohm's law in this case. So from this, that means that we have the voltage, which is 20 volts, and the only thing that we're missing is going to be the resistance. So we do have the resistance in the two resistors, but this considers V source. So the resistance value that we're going to have to find is for the resistance along the circuit, the equivalent resistance. So how do we find R total?
At 30 and 12 is 42.
Yeah, because how are these two connected?
In series.
In series. And if we look back at our formula, in series it's just going to be the sum of the two resistors.
Okay, I found this on the web for is it gonna be the sum of the two sisters? Check it out.
Or they're listening, Mr. Morales, they're listening.
Yeah, because they want to get more information so they could continue to tamper elections. That's
Only people that drink soy milk use Siri.
That's true, actually.
Yeah, we're talking about that.
Oh no. Okay, so let's add these together. It's going to be 30 plus 12, 42. I could do that. So now all we need to do is isolate for the current. So rearrange the formula. What do we get if we rearrange the formula? V over R equals to I. So 20 divided by 42. What is it? 10 over 21? No. Josephine, where are you? Help us out. Yeah, 10 over 21. And what do we do with the current value? Well, we plug it back into the formula that we wanted to find out the number of coulombs that go through in 10 seconds. So Q would be 10 over 21 amperes times 10 seconds. Because remember, what are the units of amps? Is coulombs per second. So that's how the units of seconds are going to cancel out. So what is this equal to? 100 over 21 coulombs. Was that a bit messy? Were you able to follow? Well, good thing for you is you're going to have another question to practice. But instead, I changed it to a parallel circuit and then one connected in series. So now try it out. So type your answers on Jamboard, and I'm just going to provide feedback. So I'll help you out along the way. So use Jamboard to type in the answers. Not type, but like draw them in. Hey, no one's writing anything.
Wait.
That's right. I need to build more patience. You know, when I went to Myanmar, I went to stay at a Buddhist temple for a while. And that didn't help me build patience either.
Obviously.
Yeah, well, you know, virtue. Actually, never mind. Let's stay on task.
I'll finish it.
No. Because you guys are sensitive. I'm so afraid to.
Are you afraid of offending people? That seems like a soy boy thing to do. Right, Mr. Morales? A real man would just say it, right?
No, women can say whatever they want too.
Okay, so say it.
Right, Chow? Chow, don't let him speak to you that way, okay?
But if he sees you, he will become a woman.
Okay.
Oh, Josephine's doing all the work. Let's go see what she's doing. She's so sneaky there. So the question is asking you, after 7 seconds, how many coulombs of charge pass through the circuit? So very similar to before. Is I equals to charge over the change in time. And since they're asking for coulombs, you're going to look for Q, charge. And they give you the time, so the only thing you need to do is find the current. But to find the current, you're going to have to use Ohm's law, like you were saying before. And they gave you the voltage, which is 12. So the only thing you need to do to isolate for the current is find the equivalent resistance along the circuit. So this is where Josephine is coming into play. And first, she's considering R2 and R3 in parallel. And then to find the whole resistance, she takes the resistance of 2, 3, and she's going to add it to the resistance of 1. Which is this part here. Then with that value of resistance for the total in the circuit, she finds the current value and then puts it into a formula, and then see, good, we're almost done. Oh, somebody wrote something here, 35.7, what is that? It just came out of nowhere.
Is that the answer?
No, this is a random guess, I can't follow your work.
I did the work, I just didn't write it on the Jamboard because they're already writing.
Oh, so you're a capitalist, you're letting other people do the work for you, eh?
No, I did the work myself.
Good. That's a good Labor Party. 16.5 coulombs. What's 12 over 5.1? Oh, Oscar, that's not the answer that you have. What happened?
I don't know, let me try again.
Okay, so let's give some time. Max, what did you get?
Oh, I found out. I completely forgot to take into
I got
account.
Charles and Josephine's answer.
I forgot to take into account the voltage.
Oh, and the formula for current?
Yeah, I forgot to do that.
Okay. Good, good. All right, let's go to slide 10. Now, in this one, we have a parallel circuit, but in that branch, you could have more than one resistor in it. So in each of the branches, there are two resistors, R1 and R2, and in the other one, R3 and R4. So they're giving you that the resistors R1 and R2 are equal, the value of R3 and R4, also the voltage at the source, and the current at branch 1. What do they want? The resistance at 1 and 2 and the current at 3. So I'll give you some time to think about it and then we'll take it up. Think and work it out, then we'll take it up. Okay, in this case, notice the voltage that you begin with. So the voltage gain is 15 volts. And what happens to the voltage in a parallel circuit? Does it stay the same or does it split? The voltage.
It's the same.
So we have 15 volts going to the top branch and 15 volts to the bottom branch. And while it is in that branch, it comes across two resistors. So we can think of this from the top branch. All the voltage gain at the source has to be equal to all the voltage drop in the top branch, which is going to be V1 plus V2. The bottom branch makes another series circuit. So the voltage that's gained at the source is going to be the voltage dropped at V3 plus V4. And then we're going to take advantage of Ohm's law, the virtuous one, V equals to IR, to replace these values. So instead of V3, we have I3 R3 plus I4 R4. Did that make sense?
Yeah.
Now, what do we know about the current through the third resistor and the current through the fourth resistor? How are those two related?
Should be same.
Because the two resistors here, they're connected in series. So we can say that the current at 3 equals to the current at 4, since they're connected in series. So we can rewrite this as I3 R3 plus I4. Sorry, I meant to write I3 R4. We can common factor the current at 3, so it's going to be R3 plus R4. And at this stage, all we have to do is put in all the values that we were given. The voltage at the source is 15 volts. The current at 3 we don't know. And the resistance at 3, it was given to us, 150. And at 4, it was 200 ohms. So now we can isolate for the current at 3. And what do we get in that case? Yeah, that's pretty good. Now I'm going to give you some time to do the top branch analysis. So try to mimic the same steps I just showed you, but now do it for the top branch. So continue with the formula I wrote there on the left side. Oh, today there's no Raj or no Jazz. Maybe they went to get lunch together today. It's okay, I wrote them. Wait, erase the last one? No, let me. Now, what information did they give you about the two resistors? How is R1 related? It's actually equal to R2. So what can you write instead in the brackets? Yeah, so instead of trying to isolate R1 and R2, we can think of them as 2R1, because this relationship here, they're equivalent. So it's kind of like saying R1 plus R1, which is 2R1. Does that clear the question mark? Okay, good. Yeah, and then after that, you just need to isolate for R1. And it's really clever because once you find R1, that's the same value of R2. So you kind of like, wait, I was able to say you killed two birds with one stone or something like that. But that's wrong, right?
Animal abuse.
Yeah, what's the soy boy version of that saying? Do you guys know?
Of what saying?
Or you can kill two birds with one stone. So what's the soy boy version of that?
Give me a minute to think.
Of course, Oscar. Okay, come on.
I've forgotten. I know this one is the vegan one, so I've forgotten.
You can get two tomatoes from one branch. Did that work? No. It's okay. This is a hard question.
I found it. I found the vegan one. So it is feed two birds with one scone. That's the vegan one, man. I'm not lying. That's the vegan one. Guys, no kill birds, man.
Feed two birds in one scone.
That is good, actually. That is good.
Yeah. The vegan one.
I gotta give them some credit because,
Soy boy.
yeah, thank you guys for making me more soy. It's really nice. You know why Spanish people don't like to drink soy milk? Because soy means I am, and when you say soy milk, it's like I am milk.
Okay.
Okay.
That's joke.
What's wrong with being a milk?
The jokes need to be funny. They need to be jokes.
Okay.
That's just a statement.
Good. I need to go to sensitivity class training, I think.
Feed two birds with one scone.
Wow, our friends are really working so hard. Let's go to the next slide. So in this example, we have a more complicated question, but very similar setup. Now, one question that your friends asked me from period 2, what does ma mean? $500 ma, what is that?
Microamps or milliamps? I don't know.
Oh, micro actually has letter U.
Physicists can't spell.
But no, that's the letter M with the Greeks.
Is it milliampere or something?
Yeah, milliamperes, kind of like millimeters. Right, so really, how much is 500 milliamperes?
It's a pin that you just stole my answer.
Because we want to use SI units, so you want to convert the milliamperes into amperes. So think about how many millimeters are in a meter to help you remember how many decimal places you have to move over.
1,000.
So how many decimal places are you moving? 3.
1.
No, 1,000 is 3.
Yeah, I said 4.
Oh, speaking French.
Oh, mama.
You should have said sun. I would have understood sun, but oh my goodness.
What? That I would thought it's the sun.
No, sun. Ir sansu. 4.
Okay.
Ir
sansu
sansu.
4.
No, woo. Woo.
No, Mr. Morales.
I am confused.
Wait, hold on. Mr. Morales, count in Chinese again.
I did it.
Sun, right?
Ir sansu.
So why was sun before?
Yeah, I got mixed up because ir sounds like one single word. Okay, good. So that was the question that your friends from period 2 were asking. So in this question, if you gain 15 volts at the battery source, and you come across the first resistor, and they're telling you that the voltage at the first resistor is 9. That means you're going to be losing 9 volts there. So how much do you have left over?
6.
6?
Leo.
And whenever you have a parallel branch, the 6 volts is going to get split, or it's going to go 6 at the top and 6 in the bottom.
6 on 6, yeah.
So that means 6 volts are going to the top and 6 volts are going to the bottom. So you see, you look at the voltage and you start from the power source, and then you could consider the current from the power source. But in this case, they didn't give you the current at the source, so it's not that helpful in this case. So what do we have? That V3 actually has to be equal to V2 in this case, as our friends found in this formula, because all the voltage gain equals to all the voltage drop in one branch, which is 9 plus V2. Or in the other branch could have been 15, 9 plus V2. So in this case, V2 equals to V3, which has to be 6. That was a bit messy. I should fix it up a bit. Is that better? Okay, so now that we have all the voltages, we have the resistance, we can use the virtuous V equals to IR, and you can do this at individual resistors. So you could do it at R2, you can also do it at R3. So what do I mean by this? V2 equals to I2 R2, or you could have V3 equals to I3 R3. So the voltage at 2, we found it was 6, and the resistance is given to us by 30 ohms. So what's 6 over 30? Can you simplify that? No.
Wait, you can't simplify 6 over 30?
No. Can you? 6, 12, 18, 24, 30. No, you can't.
Really?
It's 0.2.
Mama.
You can't simplify 6 over 30?
Come on, man. Don't confuse me. I'm not so good at fractions.
Are you sure?
1 over 5.
Yeah, that's why next semester I'm going to not teach math anymore.
Yeah, but are you sure you can't simplify 6 over 30?
I'm teaching grade 9 science.
Okay.
I'm sharing with you part of my life. You don't care.
And grade 9 students not.
Oh, that's fine, I know. I mean, that's cool, but are you sure you can't simplify 6 over 30?
Yeah, just put in your calculator, 6 over 30. Oh, 2 over 10. Not even 2 over 10. It's 1 over 5.
Oh.
The joke's on you, person.
I did say 1 over 5. Yeah.
Ha, Chow. Chow got it wrong too.
Yeah, it's 1 over 5. What you doing?
Okay, let's go back. We lost focus, right? Totally, I have no idea what happened there. Oh, we look at the second branch at R3 using Ohm's law formula. V3 is 6. I3, do we have I3? Yeah, they gave it to us. And just isolate for the R3 value, we get 12 ohms. 6 divided by 0.5, let's double check. 12, good. And what happens to the current after it leaves the branches? The current combines again, right? So that's going to be I2 plus I3. So it would be 1 over 5 plus 0.5. So 1 over 5 plus 1 over 2. Josephine, we need your help. How do you simplify that? So in other words, the current at 2 we found, which was 1 over 5, and the current at 3 was given to us. So when they leave the parallel branch, they recombine, which is the current in the battery as well, because the battery is going to be connected at the end of the circuit there. So if they want to find out how long it takes for 20 coulombs of charge to pass through the circuit, we're going to have to use the formula. Current equals to charge over the change in time. We found the current. The only thing we have to isolate for the change in time. So that's going to be the charge divided by the current. The charge is 20 coulombs and the current is 7 over 10 amperes. So 200 over 7. Let's double check. Okay, good. Now, one of your friends made a mistake on question on slide 9, but then they corrected it. Can you highlight the changes that you made? Because I don't know what changes you made.
So my wrong answer is supposed to go in there.
Oh, so the resistance value. So, oh, but the equation was correct. The equation procedure was correct. So it was a calculation problem. Okay, that's not so bad. All right, so that's it for today's lesson. We went over 4 examples. Now we finished the electricity unit.